When I first saw engineers waving magical wands around engine blocks and getting beautiful CAD results, I mistakenly thought that 3D scanning was magic. This video is a real-world, high-level overview of entry-level 3D scanning for CAD. I'm going to show its strengths and its weaknesses, why it may be for you or might not be just quite yet. This is not a product review. I'm just here to dispel some myths, to show what I've learned, and to learn from you guys in the comments what I'm doing wrong and how to improve. I want to start by giving Creality some real credit. Only a few years ago, this equipment was out of the reach of most professionals, let alone hobbyists or small business owners. Now we've got a full lineup that ranges from the consumer-friendly Ferret all the way up to their new professional tier Surmoon series. Most tech today, AI, kills jobs. This technology creates them. Creality is living up to its name. I'm starting my journey with the Otter Lite. It's an affordable, dual-camera structured light scanner with true stereo depth and full marker support. Its multi-camera system allows it to scan small objects underneath an inch all the way up to very large objects from 6 feet away. And if you plug it into a computer, you can capture it up to 30 frames per second. That puts it a step above Creality's lower cost Ferret and several steps above the scanning tools like you'd find on something like an iPhone. But it's nowhere near as powerful as some of their laser scanners, which are much more magical. The TLDR, it's just powerful enough to be used professionally while still being priced to be affordable for enthusiast 3D printer nerds like us. But for a real review and comparison of other 3D scanners, check out Peyo's channel, links in the description. The Otter Lite works by shining a pattern of invisible IR light onto your object, and then 2 infrared cameras watch how that pattern bends and warps across a surface. From the differences between those 2 camera angles, the scanner can figure out depth. There's also a color camera, which helps the scanner understand what it's looking at by tracking texture and features, which keeps the scan from drifting off into another dimension. This system is great because it's affordable, fast, and surprisingly easy to learn. But it also comes with one huge drawback. IR cameras can't see glossy black or shiny surfaces very well. These surfaces either reflect IR light or absorb them so they don't come back to the scanner. So what do you do if your scanner can't see your object? The answer? Scanning spray. It's a reflective powder in an evaporating aerosol. Think about old cartoons where throwing flour reveals the invisible man. It works really well, but it does smell bad, has to be shaken like your life depends on it, and if you mess up, it might not evaporate and you'll be brushing powder out of crevices with a toothbrush. It's also expensive, but even with those drawbacks, it's 100% worth it. Unfortunately, every PC part that I tried had to be used with this spray. But it's not the scanner's fault. That's just how IR technology is. Now, Creality's more advanced scanners, like the Raptor X and the new Surmoon units, don't rely solely on structured IR. They fire cross-hatched laser patterns, multiple wavelengths, and even LiDAR-style pulses. They behave much closer to the magic wand scanners we imagine. But even then, they're not the best tool for the job. A 3D scanner gives you a mesh, not a CAD model. And meshes, even perfect meshes, are terrible to work with in CAD. Yes, there is some really expensive software out there that can take your mesh and make it a solid body CAD model. If you have experience in the software, let us know in the comments. Okay, so here's an ultra detailed Sapphire Nitro Plus 9070XT PCB model. It's production CAD from Sapphire and it's exported as OBJ. It's flawless. There's nothing in the known universe that can produce a scan this clean. And yet it's still a nightmare in CAD. Edges aren't edgy. Planes aren't planar. Everything is a million tiny triangles crushing my CPU. Now I can click point to point to get a measurement or create individual construction planes, but with over 4,000 components, it would take forever. For PCBs, heatsinks, brackets, I/O shields that are very geometric and laid out in some kind of grid, there's a faster method. Just take a top-down photo. Trace it out, grab your calipers and start extruding. 3D scanners are just fancy cameras. If you're only working in 2.5D, you don't need a fancy camera, you just need a camera. I do have tutorials on how to do this, and of course you can look some more up on YouTube, but I'm not going to go into the weeds here. Now that works for circuit boards, but good luck modeling automotive parts with calipers and a couple of photos. These shapes are twisted, organic, and practically impossible to measure. In some cases impossible because I couldn't fit my calipers in there. And this is why I wanted to get into 3D scanning. To scan automotive parts, to get hired for projects, and to not lose my mind when modeling a Jeep A-pillar. My first project was a phone mount for dash cam use. The A-pillar plastic alone, zero chance I could model it, even if Blender was downloaded into my nervous system Matrix style. With texture mode and scanning spray, I captured everything I needed to model the new sheet metal bracket, and I only needed to print 2 prototypes. Without 3D scanning, it would have taken forever, and a million sea turtles would have died from all the wasted plastic. If you're a Jeep owner, you probably have an unsafe amount of ducks in your collection, i.e. 1. They bounce off under acceleration, roll underneath your pedals, and then you die a squeaky death. So I scanned the cover and dash so I can redesign the grille into a duck holder. And check this out. This is the raw point cloud. Have faith. Fused. Now with texture. Blammo. Look how good this is. This is a one-click process. Creality nailed the software, and man, it looks good. The shadows that the texture add really helped me identify the parts that didn't get scanned, like these holes for the clips, and the little sprues on this plastic cover, which just basically were blobs in the point cloud. Now you know why all the wow scanning videos are of engine parts. I did not go into detail about the scan to CAD workflow. It is kind of involved, and that's why I recommend you watch Clef42's video on scan to CAD. It's fantastic. In 30 minutes, you will understand what you're signing up for. Also, watch all of Paya's videos. This guy is basically a one-man scanning university. Tutorials and awesome reviews with comparisons of different scanners for your budget. If you have a Jeep JL, you can order this camera mount or cheese bar from my web store, or download the file from my Patreon. It has 3 1/4-inch 20-threaded holes so you can mount camera gear like your phone and use as a dash cam. Oh yeah, and it takes into consideration the cruise control sensor airflow requirements. More complex creations like my relatively simple duck pen or my very advanced solar bed are going to take more time. But this is time that I'm going to get back by properly learning how to 3D scan and implement it into my projects. Again, if you are a 3D scanning specialist, aka a metrologist, aka a magician, please share your tips, your tricks, your favorite tutorials down in the comments below. Help all of us out by sharing some of your knowledge, and feel free to correct me if I said anything wrong. Please guide me. This is the beginning of a new journey for me, thanks to the technology of 3D scanning, for Creality for making it possible to be accessible, and to you guys for supporting me. Peace.